All right, this is question 4 from the AP Calculus BC 2021 free response questions. And so we are given the information, let f be a continuous function defined in the closed interval of -4 to 6. The graph of x consisting of 4 line segments is shown above. Let g be the function defined by g of x is the integral from 0 to x of f of t dt. Part A asks on what open intervals is the graph of g concave up? Give a reason for your answer. So this information here tells us that we are looking for when g prime of x is increasing because we're looking for when g is concave up. And then we know that because g of x is the integral of f of t dt, g prime of x is f of t, and that's what we have the graph of. So we're looking for when f of t is increasing, which in this case is on the interval -4 to -2, and 2 to 6. So here and here. So that's part A. Part B says let p be the function defined by p of x is g of x times f of x, find p prime of 3. So first I would say just write out the product rule. And we have g prime of x times f of x plus f prime of x times g of x, and that equals p of x. And since we know g prime of x equals f of x, we can replace our g prime here with f of x. So we have f of x all squared plus f prime of x times g of x. So then we're going to plug in 3 because we're looking for p prime of 3. That's a prime there. And so we are looking for f of 3 squared plus f prime of 3. So that's going to be the slope times g of 3, and that's going to be the integral from 0 to 3. So first, f of 3 is -3 squared is going to be 9. Plus the slope there is 1, so 1 times the integral from 0 to 3 of f of t. And in this case, we're just going to look at the areas and count up the boxes. So that's going to net to 0, and then we have 3.5, and it's positive, so it's -3.5 plus 9, and that gives us 5.5 is p prime of 3. So that's B. For C, find the limit as x approaches 2 of g of x, x squared minus 2x. When you plug that in, you get 0 over 0, and so we can use L'Hopital's rule. And so we're just going to take the derivative of the top, so g prime of x all over 2x minus 2, and we know g prime of x is f of x, so we get f of x 2x minus 2, and then we plug in 2 because we are still looking for the limit as x approaches 2. And on top, we get, we get -4. And then on the bottom, we get 2. So overall, the limit as x approaches 2 is -2. And then for part D, find the average rate of change of g on the interval -4 to 2. Does it mean value theorem guarantee a value c on the interval -4 to 2, where g prime of c is equal to this average rate of change? And then justify your answer. So for part D, first, they're asking for the average rate of change, so we'll just do that first. So that's g of 2 minus g of -4, or 2 plus 4. And that gets us 0 plus 16 over 6. 16 over 6 is 8 over 3. So that's our average rate of change. And then they're asking if the mean value theorem guarantees a value where g prime of c is equal to this average rate of change. And so in this case, the mean value theorem does, so yes, but we also need to justify the answer. And that would be because the function is continuous and differentiable on that interval, which we know because that's given to us, and we also have the derivative of it, which is the graph of f here. And so therefore, by the mean value theorem, we know that there is a value c where g prime of c equals the average rate of change, which is 8 over 3. And that's it. So that's problem number 4 from the 2021 BC Calc exam free response questions.